We'll give you a quick overview of the companies that are involved in creating this system. We're going to talk a bit about the business challenge we were trying to solve. We're going to go into some of the ways that the system can actually evolve over time. So you don't have to create a fully connected system right out of the gate. You can kind of build it up over time. And then we'll provide a summary of the results attained and a live demo connecting back to an actual machine. So a little bit about HMS Networks. So at HMS Networks, we're a communication company. So we focus on connecting devices, right? So we want to be the best possible conduit for data and remote access. We've got about 600 people. We're headquartered in Halmstad, Sweden, and we are a public company, and we do about $150 million in revenue. Our primary customers are the largest automation companies. So Siemens, Rockwell, Mitsubishi use our products. Typically, they're using our products to support field buses that they don't internally have as their primary field bus. And then we sell to machine builders and facility owners that are looking to bridge between different machine protocols and collect data from those machines. Our product portfolio is based on a technology we call Anybus. Anybus is our field bus protocol solution. So this underlying SoC device has the ability to support upwards of 20 different field bus protocols. And then we integrate those products into gateways to create field bus converters. And we integrate it into our edge products that allow us to collect data off machines that are located both on-site or off-premises. So John, do you want to take...
Sure. I'm John with Bondtech. I'm a process control engineer. I'm an end user. I've used Pi. A little bit of history about me. I used Pi in a oil refinery, which was a continual process. And when I started work for Bondtech, it was a batch process, so it's completely different. But you know, other Pi users know it really worked in with the event frames. So we manufacture autoclaves. They're just big pressure vessels. They make wing parts, core leachers, vulcanizers, just all kinds of equipment that circle around this pressure vessel style. We have our corporate office is in Kentucky. We have worldwide sales. We just finished a job in Australia. We have sales service techs all over the world. And we just kind of ran into a problem when I first started working, which is what we're going to demonstrate and go through here. So when I first started, we had 5 techs. And if you had a problem with the machine, if you're a manufacturer and you make machines, you had a problem with the machine, we went out to go fix that machine. We'd have to schedule the tech, fly one day, work the next day, fly back. It ate up 3 days. It cost our clients quite a bit of money. And if it was an in-warranty part, of course, it would cost us quite a bit of money to get out there. If they needed to change a program or a process with what they were doing, we'd have to fly out there, connect laptops up, reprogram the PLC, come back, just noticing a massive trend of traveling all the time and expenses out. So, and I guess we also had, I put it in here, but some of you guys may have run into this. We have claims of word of mouth, well, your machine did this and this is what happened. Well, we know our machine and we know it didn't do that. We're pretty sure what did happen, but we can't prove it. So we were running into some of those issues, and that's what led us to try to find a solution that would help us, you know, fix this problem that we were having internally of all this money going out and all this time resource. So with that in mind, I had previously used OSI soft, and I knew of the data historian, I knew of the analytics capability, and I knew of the notification capability of it. So I knew that I wanted to center a solution around this. Now, most single manufacturers have one plant inside, but for us, you know, the equipment we make goes away. So we had no way to see what was happening with that equipment remotely, which then, I think it was last year or maybe the year before, we met HMS at Rockwell in Texas, and they showed us this device, and they said, yeah, you can connect to your PLC remotely. And we're like, oh man, that would save us these trips. Or, yeah, you can display what's happening to your machine. And through that, we just started with that connection. Through that, we ended up learning that we could also use it to connect to Pi.
All right. So those of you who are familiar with Pi, I mean, I believe everybody at this conference is very familiar with it, but it makes for a great remote data system. So the system is designed to allow you to manage users, so you can create different types of users that can see certain types of data. So this lends itself to allowing you to support customers, allowing them to access data while limiting the amount of data that they can view. The robust visualization that comes with Pi makes for a great platform in terms of developing dashboards. If you've already got Pi in-house and you want to extend it to a remote asset, you're leveraging the knowledge that you already have in-house with regard to that system, so you can build on top of it without adding a lot of additional cost. And then you've got so many third-party connectors built into this system, you have the ability to expose that data to a lot of different applications by passing through the Pi system. So it really makes for a great platform to build a remote monitoring solution on top of. So once we move outside the corporate internal LAN, you start talking about moving into a customer site, we're going to be running into a lot of interesting problems, and we're going to need to make sure we pick a communication solution that'll help us address those issues. And so one of the first things you might run into is you may have no network access. For example, this skid is sitting out in the middle of nowhere, so you're going to need to pick a communication solution that gives you the option to offer some cellular connectivity. And without this, you're going to run into situations where you're just not going to be able to deploy your system. Ideally, you pick a solution that offers it as an option so it doesn't add cost to every single deployment. You're going to have less physical security. So if you're at a wastewater lift station, you may only have a chain link fence. Maybe you're just limited by the box that you actually have your system stored inside. That can be broken into or forced open with a crowbar. You're going to need a network connectivity solution that ensures that even when an individual has direct access to the components inside that box, they can still not access your network. And then, of course, travel costs are key. John was talking about that earlier. You're going to need to make sure that you have a system that you can provision before you deploy it into the field. In the ideal world, you've actually got a system that you can ship to a customer and you never have to send an individual to configure that system on site. You're also going to need to consider varying IT policies. You're going to run into situations where the IT department isn't happy about the remote connectivity solution. So you're going to need to pick a communication partner that's willing to visit and meet with those IT professionals to get to the point where they're comfortable with the technology and the security built into the system. Firewalls are always an issue. Outbound firewall technology is key. We'll talk about that a little bit later. You're going to need to consider ISP performance issues. One of the things that we've noticed is cellular connectivity in Mexico, for example. We'll see the cellular connection go down a few times a day for a few minutes. So the system must be able to buffer data so you can tolerate those types of outages. And then, of course, there's new data path requests. So once you roll a system like this out, customers are going to start coming to you and asking you, hey, could you monitor this component that maybe isn't built into your system? And if you can provide them a path to get that data up into your database, you can create a stickier solution that's going to allow you to sell more product in the future. So when we look at those requirements and we start to think about OSI and HMS, the OSI platform is really a good match, as well as HMS, in the sense that HMS has built communication systems that are already managed by a platform that we maintain in the cloud. So it will support over-the-air updates, so you don't have to worry about supporting any software updates to the edge gateway itself. The edge gateway itself retains its configuration parameters, so when software updates are done, you don't have to go reprovision the device. The device can just reconnect. You're going to need to be able to offer that multiple data path support, and the solution has that built in as well. And then, of course, when we look over at the OSI Pi system, the fact that you have the robust visualization, as well as the alarming, the scheduling, you can start to build a system that will generate alerts for you. And this is going to be key in putting this platform together. I talk to a lot of companies that want to start throwing up dashboards, but once you get up to 100 machines in the field or 1,000 machines in a field, dashboards themselves aren't that useful. There's just not enough time in the day to monitor individual dashboards. And so you need a system that can generate alerts and then you fall back to the dashboards to really understand what's happening once you've received an alert. And the Pi system has that functionality built in. And then lastly, it's user management. Whether you're talking about the HMS system, which allows you to manage individual user accounts under a single administration account, and that means manage. That means you can delete the account if the individual leaves your company. You can monitor how often that individual accesses the network. You're going to need that same technology on the Pi side. So you're going to need the ability to basically determine what an individual is doing with the data in the system. So from a security standpoint, so I've got a single slide in here just to talk about security, because this is always an issue when you're working with individual customers and individual IT departments, and every IT department is different. And I can't say it again, can't say it too many times, is the fact that you're going to need to pick a partner that's willing to get on the phone with your end customer and work through any of the IT department's concerns. So at HMS, we're very proud of our design for security. So we use all the typical standards you would expect in terms of developing our products. We control our OSs entirely. We don't use anything that's just out of the box from a semiconductor vendor, so we know exactly what's in our products. We use open source VPN technology to create the remote access solution, so there's no secret sauce built into our product. We've integrated router functionality into our device, so you can limit where you can move around the network once you log into our box remotely. There's that comprehensive user management. We've gone so far as to have third-party penetration companies come in and try to attack our system, and that's that STAR certificate that's listed up there. That's important when you're building a system. And then our cloud platform does support intrusion detection, where we're monitoring on a constant basis the different software functions that we have running in that system to ensure that the integrity of each piece of software that we're running in our cloud is never compromised. So some additional considerations when you're building a system like this. Cellular data costs can obviously be an issue. You want to make sure that the system has the potential to batch data. If you can accumulate data over a period of time, it can lower your overhead considerably and reduce your cellular costs. You may want to consider transitioning from TCP connections to UDP connections. The UDP connections, again, reduce your overhead by about 50%. And then heartbeat functionality is something you'll need to think about depending on how often your device is sending data. Do you want to have a keep alive message that's guaranteeing that the connection is there at all times? With regards to outbound versus inbound transmission, this is talking about those firewall problems you might run into. If you can select a solution that creates an outbound transaction through your end customer's firewall, then that's much easier for that IT department to approve. They don't have to open a port on their firewall. The messaging will just pass through the firewall, just as if an individual is browsing the internet. Buffering is an important thing to consider, right? So do you want to buffer on the device at the edge gateway if you lose the backhaul? Do you want to potentially buffer some data in the cloud? And we'll talk about some different connectivity solutions that HMS offers in that vein. And then you want Pi-compatible timestamps. So if we do have to buffer the data, one of the problems you run into is that you're going to want that data timestamped at the edge, so that when the backhaul comes back up, you can push that data up to your historian and retain all the timestamp information. So that's an important feature. And then lastly, giving your customer control may be a way to allow you to sell this product. So allow your customer to turn off the VPN access. You can allow your customer to disable the data if they want to. Essentially, putting that control in your customer's hands helps them accept the solution.
Yeah, one of the big things we found out, I'm glad you brought that up, was when we first tried to implement this solution, we had a little bit of back push that the customer didn't have control, and you're going to always have control to get into our system. And so all of our control systems, it's just a simple switch. These devices that they sell have the ability to have digital inputs, and so you can just connect them to a light feed out if you would like to have the green light that says you are connected, and then you can give the customer also a switch if you're dealing with end customers like we are. If you're an internal group, then obviously you wouldn't have to deal with that. But when we were in our testing, We had really good internet where our servers were and really good internet where the client was, but there was still disconnections. It just always happens. So we were needing something that would buffer this data, and we sent out just the base device. Just to kind of give you a little story on the side, we sent out the base device. They have user expandable memory, so we can add memory to them, but just its base memory, sent it out. They hooked it up to a machine in Hawaii, let it sit there and run. Well, what happened was one of the maintenance guys didn't like that their corporate overlords were monitoring everything they were doing. So they disconnected the internet thinking that, well, they're not going to know what happened. It wasn't, I think it was between 32 and 35 days later, they went and connected this internet back up. Now, granted, this machine's only monitoring, I think, about 40 to 50 tags, but it's monitoring at 1 per second. So we're not talking a small quantity here, but it pulled all 35 days. It just immediately, it took it a couple minutes, it uploaded into Pi backfilled it all the way up. There was no interaction. I didn't touch a thing, and all of a sudden I saw all the trends for the last 30 days. So that was just a great selling point for us, was that it's going to buffer this data. Pi is going to bring it back in. I don't have to do anything. There's no, process control specialist trying to make this work. It's just going to work. So that, and then we also, I spoke onto it earlier, but when we had some valves issues was the example. And the valve they kept saying, well, we're blowing our pressure relief valve. And we ended up finding out through watching, because we can access the PLC and see all this data without having to send a technician out there and do this round trip cycle. We were able to figure out what it was, ship the valve out there just overnight. They replaced it, their maintenance guys replaced it, and they were back up and running. So it just gives us that live connection that we would never get to our equipment remotely before without having to send a technician out there.
All right. So let's talk about the connection between the edge gateway and the actual Pi system, because there's a couple of different ways to do this, and it's a little different whether you're on-prem or off-prem. So from a device standpoint, we've got the OSI Pi server on-premise. In this case, you've got it connected to a PLC. And one option is to use the OPC UA connector from OSI Soft. So the device supports an OPC UA server. So any tag that you contextualize in the edge gateway is presented onto the OPC UA server. So you can just use it just as if you would use any OPC UA service. And so it works very well, and we've tested this type of a connector. The other option is to push the data directly into the web API interface. So in this case, what we're running is a small program that we created on the device that allows it to interact with the web API interface in a secure way. So it is an HTTPS connection, and it can populate the data directly into the Pi database. The device will actually come up and check to see whether the Pi point exists. If the Pi point doesn't exist, it'll automatically create the Pi point and then start sending data into that Pi point. The solution can actually be expanded to create elements, because the web API interface is actually very robust in terms of what it allows you to do. So you can imagine a scenario where you have a specific type of machine that you manufacture 100 of a year, and you want to create sort of a generic element definition for that machine. That machine could then just auto-populate itself as an element as you create each machine into the Pi system. In terms of the arrows here in these diagrams, I'm always trying to indicate where the initial request comes from. So in the case of the OPC UA connector, it's actually reaching down to the OPC UA server and pulling the data. In the case of the web API interface, the device is actually pushing the data to the web API interface. So that's on-premise, works great, but what if we move it outside the factory? So the second I move onto a customer's site, I'm going to have to deal with that customer's firewall. Right? So I'm going to want outbound technology, if at all possible, that's going to allow me to just push data through the firewall as if I was surfing the internet. Now on the OSI Pi system server side, so in this case, Bondtech is running a Pi server at their facility, they are going to have to open a port on their firewall if they'd like to provide access to that web API interface. So that would be something you would need to work with your IT department on. Another option would be to use the OMF or MQTT connector relays from OSI Soft. push those over to the DCM, and then have those go over to your PI system. So it's another option in terms of working with your IT department, your customer's IT department, to make sure they're happy with the way the data is flowing through the system. So another way to solve this problem, and this is actually the way John solved it, is to use data mailbox. So in this case, what we're introducing is a temporary data storage location in the cloud. This is a small FIFO. It's a 10-day FIFO. So the data comes in, you read it out within 10 days, and after 10 days, HMS deletes it. What this allows you to do, though, is create that outbound connection from the customer site, again, firewall friendly. It goes into the data mailbox, and in this case, we're using another product from HMS called eSync, which will actually pull the data out of data mailbox and push it into a SQL database. And then we're using RDBMS to extract data from that database and populate it into the PI system. So in this case, the outbound connection from Bondtech's facility is firewall friendly. So that's really the benefit of this type of a scenario. And there's another way to do that using the UFL connector as well. You can access a RESTful API in the data mailbox and get data that way. Both cases, your IT department will be very happy with the fact they don't have to open a port. The solution is also expandable. So at this point, I run an engineering service team in North America. We haven't implemented our OMF connector, but we've evaluated the technology, and we're confident that we can implement this solution. We expect to implement it a little bit later this year. But the system could be deployed initially using the web API interface or the data mailbox. And over time, as OSI cloud services become a more attractive platform to move to, data could transition and be pushed over OMF. You could even do it simultaneously. So you could push data over OMF as well as to web API while you're evaluating OSI cloud services, for example. So the beauty there is you're not going to have to replace the edge gateway. You're just reprogramming it to send data to a different location.
So I do want to also touch base as we're getting ready to talk about our system and what he was talking about, that this device, I'm not employed by them. I just use their products, and they were just great. But this device has also allowed us another scenario that hasn't been brought up. I can send the data out, and I use a cellular connection to upload that data to me because I'm this manufacturer of this machine. We've checked with them. Sure, you guys are welcome to have this. You just can't have access to our network. Great. So we get this data coming in, but they also get the data on the inside of this device through OPC UA. So I don't have to give them, or I don't need to give them direct access to my PLC code if I've got some custom coding in there, or they have to completely understand all my tags. I can actually build an OPC UA server to the inside port of this E1 device. They can have it in their own historian or their plant management software, plus I also can have it. So it's not just a one-or. You can actually build both, and this device buffers the whole thing for both of you. So just wanted to point that out. We have used that scenario, and it's worked great. But we ended up, I'm going to talk now through this next couple of slides, and then we're going to do a demo, but of how I actually just built it. We can talk about what Pi does, what HMS can do, but how did you do it? So I found a customer in Massachusetts who we were good friends with. He said that, sure, you guys can have and connect and do whatever you need to do. We trust you guys. We've been partners for a long time, so great. We did that. So the route I went was this eSync data connection, and the reason I went that route was because where we live, we're in a small town. Sometimes we have our own ISP issues in our data center. So I didn't want a drop on my side and a drop on their side. I know it can buffer, but I still wanted to do better. So we went with this data buffering that they have and used eSync, and so it can upload and it can hold in the cloud, and then when I connect, I can get it off the cloud. So there's multiple points of we can't lose the data. We have a lot of clients that have USDA checks. They go through, they have chart recorders, and they go through and check to make sure that this cycle is run right. The biggest client we have are hospitals that treat medical waste. Those have to be proven that it was done right, cleaned right before it can be disposed of. So having this traceability and this accountability is very important, and you can even take the next step, and some of our clients are aerospace. They have to have 20 years. We have to retain their data for 20 years, or they do, to be able to prove that this part was manufactured correctly, it was run through a cure cycle correctly. So there was a lot of stipulations and regulations on what we needed to do. So that's why we went with all this extra buffering and all this technology to try to build this. Plus, it did make it a lot simpler working with their IT departments. I'll just point that out. It was great. But if you can go to the next slide,
Yep.
I'll show you. You guys have seen dashboards here, and you'll see a lot more. This is just a sample customer dashboard. This is one of their units. They can click through the units. We've built some basic analytics for them. We were noticing, we had a customer say, hey, we're ready to buy a new machine. We're like, okay, great. We'll sell you a new machine. That's no problem. And then they bought this new machine, and they were like, we still can't keep up with what we're doing. And we're like, okay, let's look at what's going on. It ended up that their operators in the room, the machine cycle would get done. It would alert them. Well, they wouldn't come unload it and reload the next one for almost 2 hours. It should only take about 10 minutes to unload a machine, reload the next cycle, and hit start. And so them being able to get this type of information, which was previously just unknown because it was never recorded, has helped make a lot of business decisions. Granted, they might not need to buy another machine, but we also are proving usefulness to them and saying, hey, we're not just here to sell you a piece of equipment and walk away. We're here to help you with what your process is. You're buying our equipment. We want to be your forever partner. We want them to call us for maintenance. We want them to call us for service. We want them to call us for the next machine. So, keeping that finger on the pulse, per se, helps us keep that customer communication, that customer connection throughout the life cycle of this machine, not just an initial sale. So, and then the next slide will show we actually built a way for them to pull reports. So on I guess it's the left-hand side, you'll see an automatic report that gets sent to them every time a cycle runs through the Pi notifications. It builds this little, through the event frame triggers, and it just jumps out to them. So this is the same information that they were previously having to keep on a chart recorder. So now they've got this in a digital form, in a digital backup. They could access this same report through an unlimited amount to the history of the data that they have with our company anytime that they've run into an audit. And we've had run into that where a chart recorder failed. Normally, they have to shut that equipment down until it gets repaired or fixed or replaced. They were able just to keep on running knowing it was there, and they actually never replaced it. They're just using this as their main recording. And then the second notification, the one on the right, is another Pi notification. Internally, we're actually monitoring to say, okay, oh yeah, this pressure vessel, it went over what it normally does. It tracks a mean or an average of what this pressure vessel normally does, and if we ever see an overshoot, it notified our internal people, and I've blued out, but it tells our internal technicians, hey, here's the name, the number, the contact, here's the location. When you guys call them, check and see what's going on, and we'll 99% of the time be contacting them before they even knew it happened, because they won't pay attention to some of those small things. So then we can try to get to what caused the problem first before we have a major problem or some type of vessel leakage, which would always be bad. So the next I'm going to do is a demo. We're actually going to connect to through the software. We're going to connect to an E1 in Florida. Believe the machine's still running. Hopefully it is, but we're going to show you as I'm connecting here. Let me just go ahead and start.
So he's going to go ahead and use the e-catcher technology from HMS so that he can log on to the remote machine, and then we'll give you an opportunity to, he'll actually look at the live data on that machine, and then he'll move over to the Pi system and show you the live data in the Pi system as well. So
this is the software that connects me to what that E1 is pointing up to HMS saying, it's kind of like a DDNS or like, hey, here I am. So it's letting me it's making that outbound connection out. Then I'm going to make the inbound connection in, so it creates a VPN tunnel between me and that device. Live demo. What else would you expect it to do? Yeah.
There we go. I had 100% confidence.
Honestly, that is the longest it's ever taken me. And I was hoping it would take place on stage. So you can tell it's made the connection. I'm actually going to click, it puts a link in here, and these are just the names that I've named them. We end up naming the E1 the same serial number as the machine that we have there. It kind of keeps our records a little bit cleaner. So this one's been online, or the connection went up and it's come down, looks like 3 hours ago. This is just kind of the default landing page, but what you guys really want to see is I'm going to show you, we're going here to I/O servers and AB logic. This one is connected to 2 machines on site. These are actually core leachers. They eat away ceramic off of metal fan blade parts for jet engines. And so these are 2 different core leachers, and so it's connected to 2. It can connect up to 3. I'm going to jump over to values. And we can see, okay, we're not running a major temp, but I just wanted to show you, this says, you might not be able to read it, but 216 degrees, 209 degrees, 214 degrees. Just kind of gives you an idea of what's happening here on this machine. Now, if I jump over to my Pi system,
So then while he's pulling that up, so that last screen you were looking at was actually the web server that's running on the edge gateway. So when he connects into that device, that Flexi device, you're actually looking at the Flexi device itself. So that's not in an HMS cloud or anything like that. And you can actually access that, even on premise as a way to visualize or see live data on the machine.
so we actually see this one's on a cool down mode, but this is that machine. You guys have all used Vision before, but it was running just a cycle and what it was doing. Now it's running its cool down. Those same temperatures are right down here that we were running. I guess they're over here. This was the SCR temperatures we were looking at. So I'm wanting to show that you can actually connect to that device and see that. And this one's set up to upload once every minute because we like to have that up-to-date data. This one runs at really high pressure, 450 PSI, which for our machines is pretty high pressure, so we want to make sure that we get that really fast. Some of the other machines that are a much more a lower end machine, they'll upload every 5 minutes, but we've never seen a problem with cellular uploads, with the Wi-Fi connection. They make Wi-Fi cards with just a hardline connection. Of course, we prefer hardline, but even with cellular, I've been working this week on a machine in Cleveland, Ohio, where I actually remote in. I'm programming the PLC, adjusting some program parameters over the cellular connection while also having this data feed back in. It works great for that gateway type of connection that you need, just really well.
Perfect. All right, that concludes the demo, and we'd be happy to take any questions anyone might have. I know we got a mic back there if anybody has a question.
Front. As Enrique would say, of course, it's in the front.
Burt Roselle, Consolidated Container Company. What about where your customers want to be able to use the same E1 to provide remote access for their internal resources or get data into their Pi system?
Well,
So I don't know if you offer that or not.
well, we have had some customers that want the data inside, so we do that OPC UA presentation so they can pull it back in. We haven't had any customers that are running Pi internally. We've actually we have some customers that want their own Pi system through what we've been presenting. They're like, hey, we want our own Pi system. So we've been able to give them that back inside as well. But that E1 can make that connection and present it both ways, and it can be buffered both ways. Yep. So it's really, that's what's been great. It doesn't matter what the client wanted or needed, we're able to give them that. And even if they needed something internally in which they said, okay, we need to see what this data is going on, that HMS product actually has a built-in HMI. You can actually build a screen to display the data that's going on. We've had some customers that want to just analyze the data. Hey, can you just give me a CSV of this thing? Sure, as it's running, there's scripting tools inside that HMS E1 device that'll actually dump out a CSV file, and then they can access it internally via FTP. Yep. So I haven't seen a way that somebody's asked us for a connection and it's not been, okay, here's how we can do that.
And if your end customer wanted to access that E1 device remotely as a VPN connection, there is actually a way to do that. At the user management level, you can create an account just for them that allows them to see only the E1s that exist on their site. And so then they could log on to those E1s. I'm not sure you'd want to give them access to the controls functionality because that would open that up for them, but maybe there is a scenario where that would make sense, and it's possible to do. Yeah.
Any other questions? I'll jog over.
Mikko Baklavar from Autotech. When it comes to the equipment data you are collecting, what's your policy on the data ownership?
It becomes a little bit of a gray area when we're talking with OSI. Soft perceives the data as two different ways. Sometimes the way you connect it and the way you bring that data is the end users. We end up talking to our end users and they understand what we're doing, obviously, before we do it. So if they want that data, we'll get them that data. It can't be in a, they'd have to have a PI system and then we could PI connect to them and give them that data. But our perspective is it was their data, their generation. We're just using it for analysis, not giving it to other people, not sharing it out anywhere else. But if they want it, they're welcome to it. Most of the time for us, they're not wanting that data. These machines up until, this is the first iteration. There's 4 manufacturers in the world that make these machines. There were 5. We bought one of them out. They have never been tied to anything yet. There's one company in the United States that has over 100 of them internally, and they still don't have any data collection on them. They just are just running them. So for us to give anything to show any type of connection to something that exists, now their minds are opening up to, oh, how can we use this? And we don't even know the extent of, we're so new to getting this data, we're just in the infancy of learning how we can utilize it. So, it wouldn't be something for us in our perspective, it's their data, we're hosting it for them, but it also, we have agreements with them that we can use their data for analysis.
Yeah. At HMS, our service agreement states that we don't retain any data. So essentially, if the data is not read out of the data mailbox, it gets deleted, and we don't retain customers' data for any reason.
Any other questions?
All right. In terms of the ROI on the system, essentially, you guys were able to save over $250K in the first year just on travel costs alone.
We ended up doing one of these repairs once every week at least. We were having to go back to check on something, and it's not that the product was a problem, it was just the quantity of the products that we had out there, along with these machines last 20 years and then you rebuild them, and then they last another 20 years and then you rebuild them. So we have some machines in service that have been in service since the 60s and 50s, so you're constantly rebuilding, so you're creating this big network, but then you only, it's that weight and balance of how many technicians and engineers am I going to hire to fix some of these things, whereas now we were able to save two to three. We were going to have to expand 2 to 3 more engineers, and now we don't have to do that. With this remote connection, and for our customers, it's that instantaneous, hey, we have a problem. Oh, give me a second. Pop up the laptop. Hey, here we go. We've got it fixed. Good to go? Yeah, we're great. Thank you so much. Blah, blah, blah. We go on. So it's just been really great for that, too.
Yeah.
We actually have one more question, if that's all right.
Okay.
Mine's not really a question. I'm John's account manager, by the way, with OSI Soft. I just want to kind of brag on him. It's fantastic to just have him come up with these ideas. And then, today's remoting into an autoclave in Florida. That's bold. But anyway, yeah, great job, guys. I've been real impressed with, your ability to put together a solution and make it work so well.
I like it. I like the plug.
All right.
All right. I think that's it. Thank you very much for your time.
Thank you.